transmission lines, and their general operation and characteristics in a power system. A transmission line is a circuit that is used to transmit power from one location to another. These transmission lines can span short distances of a few hundred meters to spanning very long distances in the magnitude of hundreds of kilometers. The two techniques of line protection we will address are distance relaying and line current differential. We will first look at distance relaying. Transmission lines that are protected using distance relays are usually at least 1 kilometer in length and can reach distances of 750 kilometers or more. Transmission lines consist of conductors that are supported by structures to hold the conductors high above the ground. These conductors are connected to the structure using devices called insulators. These insulators ensure that there is no electrical connection between the conductors and the supporting structure. The structures supporting the conductors can be constructed of wood, metal, or concrete. The material that is used in the structure, the physical arrangement of the components used, and the geography that the conductors and towers are located in greatly affects the electrical properties of the line. All of these factors must be considered when determining the best method of protecting the transmission line. In a power system, the area that constitutes a transmission line is defined by well-defined boundaries. This physical location of a line boundary is often called a terminal. The terminal can be a switch, a breaker, a bus, or a transformer. Transmission lines can be broken down into one of four main classifications that describe their configuration, the function they perform, and their location in the system. Parallel lines describe a configuration where multiple transmission lines run side by side. This is done to transmit large amounts of power from one location to another, in addition to providing a redundant path for power in case one of the lines were shut down due to a fault. Interconnector transmission lines are used to connect one section of a power system to another. Generator export transmission lines are used to transmit power from a generating station to the rest of the grid. Process plant load transmission lines are used to transmit power from transformers or switching stations to large industrial complexes. Transmission lines are classified into three categories that describe the presences of generation or possible sources of fault current that might be found at the transmission line's boundaries. These are single-ended, double-ended, and multi-ended. A single-ended line, also called a radial line, has a source at only one end. This type of line is used to deliver power from the source to a load at the other end of the line. Obviously, whenever a fault occurs, there is only one source of current to feed the fault. A double-ended line has only two boundaries, each of which can have a source of fault current available. This type of line is used to deliver power usually in different directions at different times. If a fault occurs on this transmission line, current will be fed to the fault from two locations. A multi-ended line has more than two boundaries, each of which can have a source of fault current available. At the time of a transmission line fault on this type of line, the direction of normal power flow can be highly variable, and the fault will be fed from many different locations. Sometimes the transmission line itself will be tapped to provide a source of power to a load. Distance protection is one method of protecting a transmission line in this configuration, and will be covered in detail later in this section. The voltages that are used for transmission of power over transmission lines are split into three categories. These are distribution levels, which are in the range of 2 kilovolts to 50 kilovolts, sub-transmission levels, which are in the range of 30 kilovolts to 150 kilovolts, and transmission levels which are greater than 100 kilovolts. Most applications that use distance protection are 50 kilovolts or greater. The lengths of transmission lines have also been classified into three categories. Short transmission lines are ones that are less than 80 kilometers in length. Medium transmission lines are ones that are roughly between 80 kilometers to 240 kilometers. Long transmission lines are ones that are greater than 240 kilometers in length. Shunt capacitance occurs between the transmission lines and the ground. This capacitance counterbalances some of the inductance by adding leading MVARs on the line and helps bring the current and voltage back to unity power factor. Typical three-phase MVAR values are 1.3 to 1.5 megavars per kilometer for 500 kilovolt lines and 0.15 to 0.4 megavars per kilometer for 230 kilovolt lines. Caution needs to be taken when transmission lines are used with high voltage potentials. Due to the Ferranti effect, the shunt capacitance on the line can become so large that the voltage on the far end of the line can rise higher than the normal line potential.